Okay, if you turn to page 41 in your packet, this do now is a review of direct variation, page 41. So what we're going to do is I'm going to do like one of each type of problem, and then as a do now, you're going to finish the rest of the problems. We're going to do all the definitions up top together. So this says a direct variation between two quantities is a relationship in which the ratio of one quantity to the other quantity is constant. That's a mouthful, but they're basically saying you have a constant of proportionality. And a direct variation can be written as an equation in the form y equals ax, where a represents the constant of variation. Okay, and the graph of the direct variation is always a straight line that goes through the origin. Okay, now these, especially this and this, you must know. That will be on the quiz. You must know that. Okay, so we're going to do one of each type, but after we're done, you're going to finish this as a do now. So first, this says determine whether each of the tables below represents direct variation. Well, how we do that, we know that A has to be a constant, y over x. So we're going to put 6 over 1, which is 6, 12 over 2, which is 6, 18 over 3, which is 6, 24 over 4, which is 6, and 36 over 6, which is 6. So this is yes. This is direct variation. A equals 6. Okay, so you're going to do the rest of the problems in this column the same way by seeing if y over x is constant. Okay, so now let's look in the second column. This says tell whether each equation represents direct variation. If so, identify the constant of variation. Okay, well, A is definitely direct variation. The constant of variation is 6. How do I know that? Because it's in the form of y equals ax, or it's in the form of y equals mx plus b, where b equals 0. Now, b is not direct variation. How do I know that? Because b does not equal 0. In this case, b equals -1. Okay, so you're going to do the rest of the column. And then the next says, graph each direct variation equation. Okay, well, I know I always start at 0, and in this case, m equals 3 over 1. So I rise 1, 2, 3, I run 1. Or I go down 1, 2, 3, and I run 1. So you know you're always going to start at the origin. And for something like this, you're going to solve for y. And you're not going to graph it until it's in slope-intercept form or direct variation form. Okay, so you go ahead and finish all of these, and then the teacher will go over the answers with you when the whole class is done.